So yesterday we've talked about the characteristics of stars, what astronomers are looking at when they try to categorize the stars. So the two things that they look at were temperature, which is also the color, and luminosity, which means the brightness. So now that they have that information, how do they organize the stars? Well, the way it's organized is in a diagram called the Hertzsprung-Russell diagram, named after the scientist who developed it. It's essentially like a large graph. So when you look at an HR diagram, if you look at the x-axis, along the x-axis you see there is temperature or color or something called spectral class. So anything along the bottom, or sometimes it's the top, represents the temperature. Now, if we look at the pattern, it's actually opposite of what you might expect. Our coolest stars are going to be on the right, and temperature is increasing as we move across to the left. So our hottest stars are going to be anywhere on this left side. Now, the y-axis is for your luminosity or brightness. So when we look at reading the brightness, at the bottom, the stars are the least bright or said to be dim, and brightness increases as you go up. So when you look at a star at the top, it would be considered very bright. At the bottom, very dim or less bright. Now remember I've said everything is compared to our sun because the sun is what we know is our closest star. So the sun is pretty much considered average in everything. They assign the luminosity a value of 1. It's about average temperature around 5,800 degrees. So we're going to compare everything to the sun. So when we look at this diagram, if you find a star in this top corner, right, so if we have a star here, we could best describe that star as being very hot because it's all the way to the left, and it's very high, meaning it's going to be very bright. So anything up in this area is extremely hot and extremely bright. Now, if we have a star down here, we're still going to be hot because we're this far over, so it's still going to be extremely hot. And then we look at temperature, it's going to be less bright, so instead of bright, it's considered to be very dim, low luminosity. If we have a star over here, now we're on the cooler side, so these are going to be the coolest stars, so it's going to be a cool or a low temperature star. And it's also down low, so it would be considered very dim. If we have a star in the top, up here, we're still on the cool end of the spectrum as we go up, so it is still a cool star. But it is considered to be much brighter because it is higher on the diagram, so it's cool and bright. So when you're reading the diagram, just look at the pattern. Coolest stars on the right, getting hotter as we move across. Remember we said that the coolest stars are red in color. The hottest stars are blue, white, or blue. As we go from the bottom, we have dim stars to the brightest stars up at the top. The higher you go, the brighter it is. So those are the general patterns that we look at. Now, another thing that scientists look at are the groupings. So we're going to see the groupings. Let's take a look at other diagrams. All right, so let's take a look at this first diagram. On this HR diagram, you notice that they have labeled some regions. So if we take a look here, you see down here in the bottom, we have some white dwarfs. Up here, you're going to have your supergiants, and then you have a large scattering of giants. But look at the diagonal, all the way through here. These are considered the main sequence stars. Remember we said about 90% of all stars are currently main sequence stars. So that diagonal indicates those main sequence stars. Look at the patterns. Main sequence stars can be really cool and dim, or they can be very hot and bright. White dwarfs, supergiants, and giants. Now look at our labeling. It's labeled as spectral class. I don't have the exact temperatures, but I have spectral class, which is another representation of temperature. I still know, based on the pattern, this side is going to be the cool side, and this side is going to be the hot side, right? Because as we transition across, temperature is increasing. So I know these stars down here have to be the cooler stars. Now another version of the HR diagram. This one actually has surface temperatures, still has brightness, okay? And it even gives me the colors. Stars are still grouped. Okay? They're still my main sequence. You notice the groupings stay in about the same position. Let's take a look at another one. Again, I still have my luminosity. Right? I have my spectral class, but with this one I also have the temperatures. So you can see spectral class M are the coolest, spectral class O are the hottest. Now my groupings are not labeled, but knowing the pattern, I can still see that there are stars here. There's a grouping around here. We've got some here. And then the pattern stays the same for those main sequence. So even without the labeling, you can identify the groups of stars. And then finally, another example. You notice over here we have brightness referencing the number of suns. Remember I said we compare everything back to our sun. We have our surface temperature. Our groupings are labeled supergiants, giants, main sequence, and white dwarfs. So when you're given an HR diagram, it's really about just being able to read or interpret it. So if I take a look at this diagram, I'm going to go back to this one. I know that Barnard's star is really cool because it's over here, and it's down here, so it's not very bright. By comparison, I know that Betelgeuse is also relatively cool, but it is much brighter because it's higher. Right? So the HR diagram is really just reading a graph, and that's all you need to be able to do.